Hi everyone, I'm Ben Aird, founder of Semper Forged. I'm a marine musician by day, a blacksmith by night, and a dad all the time. Welcome to my channel. I started this channel because I wanted to make blacksmithing accessible to the everyday Joe. You don't need a power hammer the size of a tank, or a grinder that costs more than your first car to make a great knife. Sure, those tools make life easier and cleaner, but with a little elbow grease and maybe a few band-aids, a lot of band-aids, you can make something awesome. So here's my origin story. Like a lot of folks, I got hooked on the show Forged in Fire. I'd watch it non-stop. Finally, one day my wife said, "Instead of watching other people do it, why don't you learn yourself?" So she signed me up for a basic blacksmithing class, and that was it. I was hooked. I was hooked faster than my daughter can throw a book at my eyebrow. That's a true story, by the way. I learned basic blacksmithing on a coal forge, but later I got a Mr. Volcano propane forge and set it up in my garage. It's nothing fancy, but it gets the job done. I don't think they make Mr. Volcano anymore, but you can get similar ones from Amazon for around $100. My hammer, part of a $40 Amazon set. My anvil, a cute little 55-pounder from a buddy who took that first class with me. Here's the moral of the story. You don't need fancy gear. You just need determination, a bit of fire, and a hammer you're not afraid to swing. And some patience, because you're going to suck at first. I started this blade with some 8670 carbon steel from Pop's Knife Supply. I usually buy from Pop's, but there are a bunch of great suppliers of steel in the US. Jantz, New Jersey Steel Baron, Alpha Knife Supply, there's many others. Just look online, you can find some good deals. Carbon steel is an awesome steel to learn on. It's forgiving and responsive. For this project, I went with a full tang construction. That means the steel runs the whole way through the handle. It's tough, durable, and especially perfect for outdoor use. You'll also see me talk in other videos about hidden tang or through tang construction on knives. They've got their own advantages, but for a solid EDC, in my opinion, full tang is the way to go. Off camera, I annealed the blade. Basically, it means I heated it up in the forge and then shut off the forge and let it cool slowly inside. That softens the metal so I can grind it and drill holes for the handle pins. Anyway, what you see here is me cutting the pieces for the handle scales using a handsaw, since I don't have a bandsaw yet. Most of my handle materials come from Maker's Material Supply or Texas Knife Maker Supply. These ones are from Maker's Material, and they are curly maple, dyed, and stabilized. Before gluing up, I clean the handle pieces with acetone. You gotta get rid of oils and dust so the epoxy bonds properly. This is a step that cannot be skipped. For the glue up, I used West System epoxy. It's my go-to, and I tinted it black since I'm using black G10 spacers. I've learned that when you've got black spacers, black epoxy hides any tiny inconsistencies or gaps perfectly. If I'm not using black spacers, I'll keep it clear. Otherwise, you'll see dark lines where you don't want them. In this case, though, it's perfect. Now for the shaping. I use a Buck Tool 2x42 grinder. It's been a huge upgrade from where I started. My first grinder, and that's in air quotes, was literally a handheld belt sander clamped into a bench vise. Yeah, not necessarily OSHA approved, but it got the job done. Then I upgraded to a Wen 4x36 from Facebook Marketplace, and finally the Buck Tool. Honestly, most of my gear came secondhand. Marketplace is a treasure trove if you know what to look for. Next, I marked and drilled holes for the handle pins. The drill press? Yep, another Marketplace find, $35. Off camera, I did the primary grind on the bevels. I don't take them all the way down before the heat treat though. Too thin and they'll warp in the quench. Here you see me firing up the forge again in preparation to stamp my maker's mark into the blade and to quench. The day that I did this, it was below freezing, so I wanted to warm up the oil with a piece of mild steel. Cold oil can cause a bad quench. Here's my logo. It's very special to me. I'm active duty in the Marine Corps, and I designed this as an homage to the Eagle Globe and Anchor, but instead of an anchor, it's got hammer and tongs. With all the stress that the forging process causes in the blade, I ran 3 normalization cycles, heating it up and letting it all air cool 3 times. That evens out the grain structure and makes for a stronger, more consistent blade. While it was cooling, I sanded the handle scales even. Off camera, I glued on the black G10 spacers. I almost always use a spacer. I love the contrast it gives between the handle and the blade. You'll see it in the final product. After normalization, I brought the steel up to a non-magnetic temperature and then I quenched it in oil. If done correctly, this process will take the steel from that softened state from earlier and it will make it really, really hard. So I test it with a file. If the file bites, it's soft. If it skates, it's hardened. This one skated beautifully. After the quench, there was a slight curve, so I clamped it between angle irons and put it in the oven. It's just a regular toaster oven for 2-hour tempering cycles at 400 degrees. Like I said before, right after a quench, the blade is super hard, but the problem is it's also super brittle. If you drop it, there's a chance that it could just shatter. Tempering in a toaster oven like this reduces hardness a bit, but it also adds toughness. So instead of cracking if dropped, it flexes and survives. And when I took it out, it was straight as an arrow. We're getting closer. Next up is the final grind. It's important to always keep your water bucket nearby because grinding heats up steel fast. If it gets too hot, it'll ruin your temper, and no one wants a soft edge after all that work. I didn't grind the flats smooth on this one because I wanted a brute de forge finish. That's when you leave the forge scale on the blade. That oxide layer not only looks awesome and handmade, it actually helps food release when cutting. So yeah, it's cool and functional. Most of my grinding starts at a 36 grit where I just hog off material. Then I move up through 80 and 120. If you're going to splurge on anything, make it belts. I get mine from Combat Abrasives. They last longer and make a big difference. Now we're at the most time-consuming part, hand sanding. I sped it up even more than the other parts of the video because honestly it takes forever. But I don't mind when I'm doing it. I throw on a podcast or an audiobook, zone out, and go through the grits. I start at 150, then go to 220, 320, 400, and finally 600. I made a little sanding rig out of scrap wood and a clamp. I use a piece of mild steel with handles to wrap the sandpaper around. And yeah, the vise, of course it's secondhand. After roughly 1,000 years of sanding, we're finally ready to attach the handle scales and finish the knife. I marked and drilled the holes for the pins, including a special Marine Corps logo pin for the guy I'm making this knife for. It's someone I served with in the Commandant's Own, the Marine Drum and Bugle Corps. However, here's where I made my biggest mistake. See if you can spot it. The middle pin is slightly off-center on the lighter maple section. It really doesn't affect anything, but man, it bugs me. I'll see that pin in my dreams. Before final glue up, I shaped and polished the front end of the scales. It's much easier to do now than after everything's glued together. The drill press doubles as my buffing machine, with a tiny little polishing wheel and compound. Then I flatten the backs of the scales on sandpaper over a granite plate to make sure everything is perfectly flush. Once again, I cleaned all the pieces with acetone. No grease, no dust, no excuses. Then came the final glue up. Black tinted West System epoxy. Pins inserted, spacers aligned, and a little hammer persuasion to get that marine pin seated just right. Yeah, so I got epoxy everywhere. My workbench, again in air quotes, is actually a solid wood dining table I got secondhand, so I throw cardboard down to protect it. After wrestling everything into place, I clamped it all up and let it cure for 24 hours. Next day I unclamped, ground down the pins, and sanded the scales flush to the tang. Then I was off to the races with more hand sanding. Yes, again through 150 to 600 grit. It goes faster this time because you're sanding wood mostly. Oh, here you can see that off-center pin. I call it a reminder of humility. Back to the drill press for buffing. Honestly, that thing's the MVP of this shop. After buffing, I sharpened the edge using a whorl sharpener and then stropped it on leather until it was razor sharp. Here's the obligatory paper test. That paper didn't stand a chance. Finally, a coat of axe wax for protection and shine, and this knife was done. There it is, a hand-forged, everyday carry knife, built start to finish with budget tools, a small shop, and a lot of determination. Like I said before, you don't need a power hammer, a 2x72 grinder, or a hydraulic press to start bladesmithing. Start small, learn as you go. Every time you light up that forge, you'll get a little better. Hey, if you stuck around this long, thanks so much for watching. I hope you enjoyed this video as much as I enjoyed making it. And if you did, hit the like, subscribe, and please stick around for more. I've got plenty more builds, stories, and steel ahead. Semper Forged.